Alrighty folks, today we are looking at the binomial theorem. I know it says notes 8.5. Technically this is in chapter 8.5, but we don't need all of chapter 8. And it does fit in this current chapter because basically we're going to be multiplying out and getting a big, long, not polynomial function, but this big, long expression similar to a polynomial function. So it fits in with this multiplying out that we've been doing. Okay, so this is the binomial theorem. We have this x plus y, so some binomial raised to the nth power. And we end up getting this really long expression. So how long it is depends on the size of the exponent. All right, so the thing is to notice the pattern. So these c's, notice it starts as NC0, NC1, and then ends here as NCN. So this is called a combination. Combi, not combo. So, all right, and this is on our calculator. So we can evaluate these on the calculator, or we can evaluate these using Pascal's triangle. So hopefully you might have seen that in Integrated 3. All right, so the key is to recognize the pattern. They start with NC0 and end at NCN. Then the thing is to notice the x's. The exponents start high and end low. So the x's, or whatever's in the first spot, starts as x to the n, and the last term ends with x to the 0. The y's, or what's in the second spot, notice go the opposite direction. They start low and end high. So they start with y to the 0 and end with y to the n. All right, so we're going to follow this pattern. And I did them in the same color so you could see the pattern here. So we have 2x minus y to the 4th. So that's our n. N is 4. So we have 4c0, 4c1, 4c2, 4c3, 4c4. Then whatever's in the first position starts high and goes low. So 2x to the 4th, 2x cubed, 2x squared, 2x to the 1st, 2x to the 0. Whatever's in the second position starts low and goes high. The negative sign stays with the y, because notice this was a plus. So that would be like saying plus negative y. So we have the opposite of y to the 0, the opposite of y to the 1st, the opposite of y squared, the opposite of y cubed, and the opposite of y to the 4th. Okay, so this is in your calculator. So 4c0 is actually just 1. Then we do 2x to the 4th. 2 to the 4th is 16. X to the 4th is x to the 4th. Anything to the 0 power is 1. Plus 4. 2x cubed becomes 8x cubed times the opposite of y. Plus 6 times 4x squared times y squared. Plus 4 times 2x times the opposite of y cubed. Plus 1 times 1 times y to the 4th. And then just multiply out each of those to get 16x to the 4th minus 32x cubed y plus 24x squared y squared minus 8xy cubed plus y to the 4th. All right. And I know it's really complex at first, but once you keep practicing it, you get the pattern down. And once you get the pattern down, it becomes a lot easier. All right, so B, we have 8 minus 4 cubed. So n is 3. So 3c0, 3c1, 3c2, 3c3. Whatever's in the first position starts high and goes low. So a cubed, a squared, a to the 1st, a to the 0. Whatever's in the second position starts low and ends high. So negative 4 to the 0, negative 4 to the 1, negative 4 to the 2, negative 4 to the 3rd. So I can evaluate this on my calculator or using Pascal's triangle. So I get 1 a cubed times 1, 3 times a squared times negative 4, 3 times a times 16, 1 times negative 64, and then multiply out each individual term. So this is a cubed minus 12a squared plus 48a minus 64. Okay. But sometimes they don't ask you to write out the entire expansion. They just ask for a specific term, and you don't want to have to go through all this work just to find that specific term. So that's where this pattern is really, really important, is to understand what's going on. So for example 2, we're going to find the asked for term. So we want the fifth term of a plus 2b to the eighth. So what I like to do is just write out 1, 2, 3, 4, and then here's the term I'm looking for. So now I'm going to follow these patterns. So this would be 8C0, 8C1, 8C2, 8C3, 8C4. Whatever's in the first position, a to the eighth, a to the seventh, a to the sixth, a to the fifth, a to the fourth. Whatever's in the second position, 2b to the 0, 2b to the first, 2b to the second, 2b to the third, 2b to the fourth. And now use my calculator. This is 70 times a to the fourth times 16b to the fourth. Multiply that and we get 1,120 a to the fourth, b to the fourth. All right, so here I want the eighth term of 2x minus 3b to the 11th. So again, I'm just going to go 1, 2, 3, 4, 5, 6, 7, and then here's the eighth term. So I'm going to start with my c's. 11C0, 11C1, C2, C3, C4, C5, C6, 11C7. Whatever's in the first position starts high and goes low. So 2 to the 11th, 10th, 9th, 8th, 7th, 6th, 5th, 2x to the fourth. Whatever's in the second position starts low and ends high. So negative 3b to the 0, to the first, to the second, to the third, to the fourth, to the fifth, to the sixth, to the seventh. So negative 3b to the seventh. Calculator time, this ends up equaling 330. This is 16x to the fourth. This is negative 2,187b to the seventh. Still using my calculator, 330 times 16 times negative 2,187 is negative 11,547,360, x to the fourth, b to the seventh. And that finishes up the notes for binomial theorem.